Good morning, class. Today we're learning to solve rational equations. So our essential question is, how do I solve rational equations? Learning intention. I am learning to solve rational equations. So for the warm-up, we need to remember how to do cross multiplication. If there's only one variable, it's fairly easy. You just multiply at the diagonal and divide going up or down. So you multiply at that diagonal and then divide going up. So it's 30 times 7 divided by 5. Okay, that's one way to do it. Or you can simply look and say, okay, 5 times what is 30? Well, 5 times 6 is 30. So I also have to multiply 7 by 6 for my bottom number. 7 times 6 is 42. And I'm done. Okay, pause the video and see if you can do the next one on your own. Well, I do hope you tried. If you understood how to do it, then you are understanding concepts. So looking at this, we still have to multiply at the diagonal and divide going down. 6 times 30 divided by 36. Or 6 times what gives me 36? 6 times 6 is 36. What times 6 gives me 30? That would be 5. And the answer is 5. Okay, if you only have one variable, then all you have to do is multiply and then divide. You always multiply at that diagonal. If you've got two variables, you have to actually do the cross multiplication. So x will be multiplied with x, and 2 will be multiplied with 18, and they will be equivalent. X times x is equal to 2 times 18. X squared is equal to 36. What is the opposite of squaring? Square rooting. So x is equal to positive or negative 6. So looking at that, the cross multiplication is what we use to solve rational equations. So let's go into the next one. The next one is also review. How do we simplify? Well, we've got to factor everything. So if I am looking at this, I've got x squared minus x minus 6. So I'm looking for factors of 6 that differ by 1. One's positive and one is negative. So what are my factors of 6 that differ by 1? 1 times 6 is 6, but 6 minus 1 is not 1. 2 times 3 is 6. 3 minus 2 is 1. This number is negative, so the 3, the bigger number, has to be negative. So it is x plus 2 times x minus 3. Okay, for the second one, factors of 4 that differ by 3. One is positive and one is negative. This time the bigger number is going to be positive. 1 times 4 is 4. 4 minus 1 is 3. So the 4 will be positive and the 1 will be negative. Okay, so we factored everything on top. What about what's on the bottom? Well, it's the same idea. And we're looking at the first, we're looking for factors of 8 that add up to 6. Both of them are positive. So factors of 8 that add up to 6. Okay, 1 times 8 is 8. 8 plus 1 is not 6. 2 times 4 is 8. 2 plus 4 is 6. We're done with the first one. Now for the very last one. Factors of 3 that differ by 2. One is positive, one is negative. Remember, this is a positive 2 down here. Well, there's only 2 factors of 3. That is 1 times 3. The 3 will be positive because the 2 is positive. Okay, so now we are going to eliminate. If we see the same number on top and bottom, any number divided by itself is 1, and we can eliminate. X plus 2 on top, x plus 2 on the bottom. X minus 3, that's x plus 3, that's not the same. X plus 4 on top, x plus 4 on the bottom. X minus 1 on top, x minus 1 on the bottom. We are left with x minus 3 over x plus 3. Okay, now, as always, when we're doing this, there are certain numbers we cannot use. We cannot divide by 0. So what numbers will give us 0 in our denominator? Well, let's get started on our constraints or restrictions. What's the opposite of positive 2? Negative 2. What's the opposite of positive 4? Negative 4. What's the opposite of positive 3? Negative 3. What's the opposite of negative 1? Positive 1. So x cannot be equal to negative 2, negative 4, negative 3, or 1. So when we're getting ready to do this, this is kind of the steps you think about. Remember to set it up as a proportion. A number like 5 can be written as 5 over 1. Cross multiply and solve, and then check for restrictions. So as we're looking at this time we will do our cross multiplication. Although we could say x plus 5 is equal to 4 times 5 divided by 12. We could say that, but this time we're going to set up the cross multiplication with our x there. So in parentheses, x plus 5 times 12, close your parentheses, equals 4 times 5. Okay, all mathematicians absolutely love to make their life easier. So as I'm looking at these two sides, I realize I can factor out a number. What number can I factor out? If you said 4, you would be correct. 4 divided by 4 is 1. 12 divided by 4 is 3. So x plus 5 times 3 is equal to 5. Now I'm ready to start solving. Order of operations says I do parentheses first. In this case, we're doing the distributive property. 3 times x is 3x, plus 3 times 5 is 15, is equal to 5. Now it's a two-step equation. Step 1, subtract 15 from both sides. 3x is equal to negative 10. Step 2, divide by 3. and x is equal to negative 10/3. Okay, I look up here. Do I have any restrictions? No, because both of those are numbers. And we can always divide by any number except 0. Okay, so as I'm looking at this next problem, if I think logically, I'm done. Because x minus 7 and x minus 2 can never ever be the same number. Because if I take a number and subtract 7, it will not be equal to a number, the same number subtracted 2. But just to prove it, this would be over 1. So it will be x minus 7 is equal to x minus 2, because I will be multiplying both sides by 1. When I subtract x from both sides, I end up with negative 7 is equal to negative 2. Well, that will never ever in my lifetime happen. So in this case, there is no solution. If there was a solution, then we would also have the restriction that x could not be equal to 2. But if there's no solution, then that is a moot point. Okay, so let's look at the next one. We've got 1 divided by 3x minus 2 divided by the quantity of 2x minus 3. I need to set it up as equivalent proportions. So how do I move this to the other side? I'm going to add it. And I end up with 1 over 3x is equal to 2 over 2x minus 3. Now, in this case, because I've got variables on both sides of my equal sign, I have to do the cross multiplication. So, here we go. 1 times 2x minus 3, 3x times 2, okay, when I multiply by 1, nothing changes. So I end up with 2x minus 3 is equal to 3x times 2 is 6x. Okay, take a minute, make sure that you are good with the math. Okay, now I've got to get my variables to the same side, so I'm going to subtract 2x from both sides. Negative 3 is equal to 4x. Now I divide by 4. Negative 3/4 is equal to x. That is my answer. However, when I look back up here, I've got restrictions. I know that 3x cannot be equal to 0. 2x minus 3 cannot be equal to 0. Those are my two restrictions. So as I'm looking at this, x cannot be equal to, what times 3 gives me 0? That would be 0. Or, if I'm looking at this one, I add 3, and then I divide it by 2. So those are your two restrictions. You don't have to set them up like this. You can go from this to the end if your brain works that way, and that's fine. So, as we're looking at this, There's different ways to do it, and you're going to do it the way that your brain processes. For the last one, once again, to set up those equivalent fractions, this will be over 1. So I've got 1 times 6 minus 3x, or 6x minus 18. So 1 times 6x minus 18 is equal to 5 times x minus 3. 6x minus 15 minus 18. I keep wanting to screw up that second number for some reason. 6x minus 18 is equal to, do your distributive. 5 times x is 5x, minus 5 times negative 3 is 15. Start simplifying. Start solving. Subtract 5x from both sides. X minus 18 is equal to negative 15. Now I add 18 to both sides. Okay, x is equal to negative 15 plus 18 is 3. Okay, so I found out what x is, but let's look at our restrictions. X minus 3 cannot be equal to 0. Can't be equal to 0 because I can't divide by 0. The opposite of negative 3 is positive 3. So although 3 works, it is also one of our restrictions, so we cannot use it. So again, there is no solution. Okay. I know I am successful when I can solve any rational equation. So we're using cross multiplication. And that is how we solve rational expressions. Also, very important is to remember the constraints or the restrictions.